let's start off understanding that fractions and decimals are the same thing. And let's go back to money. If I have a fraction 1/4, I just think of what's 1/4 of a dollar. Well, I know 4 quarters make a dollar. And if I had one of them, well, that would equal 25 cents. If I had half a dollar, what would that equal? Well, half a dollar is 50 cents, and so I write that as the decimal. So using a dollar as our whole, we're able to get the decimal equivalent of our fraction. It's pretty simple. Just think of money. When we are given a fraction, we always have a numerator, which is our top number, and a denominator, which is our bottom number. And what we have to clearly understand is that the denominator tells us how many pieces we need in order to make one whole item, whatever it is that we're talking about. I like to use the example of a car. If it takes 7 pieces to make a car, then we need all 7 of them in order for the car to actually work. In this case, we only have 3 out of 7. So let's say that we call up another car part shop and we order some more parts. When that order comes in, there's 8 new parts. Well, I only need 7 of them in order to make a car. I want to know now, how many pieces do I actually have in stock? Well, I know that it only takes 7 pieces to make my car, but I've got 3 here and 8 here, and when I add those together, I get a total of 11. Now, if I take a look at the pieces that I have total, I've got 11 pieces, and I have 7 that I need to make a whole. Well, we are going to use tape models. I'm going to draw a rectangle that has 11 boxes in it, and I'm going to be sure to split up those boxes. This represents our 11 pieces that we have in order to make our car. I need 7 of them. So let's highlight. 1, 2, 3, 4, 5, 6, 7. This right here is going to allow me to create one whole. And in this case, it's going to be one whole car. Now, how many pieces do I still have left over? I don't have enough to make another whole car, but I have 4 pieces. And that would be 4 out of 7 that we need in order to make another car. So we would say in this case that 11/7, the improper fraction, is equal to 1 whole and 4 pieces out of 7 pieces that we actually need to make another whole. And this is taking an improper fraction and changing it into what we call a mixed number. All right, what happens if we have an operation where we don't have common denominators? Well, what I like to say is, let's make sure that we have a level playing field. Let's make sure that we're talking about the same number of pieces that it takes to make a whole. In this fraction, it takes 3 pieces to make a whole. In this fraction, it takes 4 pieces. But we can find some common ground. They're called equivalent fractions. So let's look at 2/3 first. If I go ahead and take 2/3 and I multiply both the top and the bottom by 2, 2 times 2 is going to give me 4, and 2 times 3 is going to give me 6. Okay, let's keep going for a little bit. If I take and multiply the numerator and denominator by 3, 3 times 2 is going to give me 6, 3 times 3 is going to give me 9. So far, I'm doing all right. I'm going to try 4. 4 times 2 is going to give me 8, and 4 times 3, and 4 times 3 is going to give me 12. So now let me try it with 1/4. We started with 2/3. Let me try 1/4 and see if we can find something that's a common denominator. There's no 4 in any of these denominators, so I got to change it here. I'm going to multiply both the numerator and denominator by 2. 1 times 2 is 2. 4 times 2 is 8. Well, 8 isn't a common denominator that matches up with any of these. So I'll try the next one. I'll multiply the numerator and denominator by 3. 1 times 3 is 3, and 3 times 4 is 12. I've seen that number before. 12 is our common denominator for each of these. And so now I can go ahead and use 8/12 in place of 2/3, and I can use 3/12 in place of 1/4. So let's rewrite this to show you what it really means. Here's my 2/3 minus 1/4. Instead of 2/3, I'm going to use 8/12. Those mean the same thing. And instead of 1/4, I'm going to use 3/12. This is way easier to subtract now. We know that our total is going to take 12 pieces in order to make a whole. If we have 8 pieces, but then we went ahead and maybe sold 3 of them or got rid of 3 of them, how many are left? That's 5. And this is a fraction that's reduced to lowest terms. So that's our answer. So using equivalent fractions is a way to get common denominators. In this case, our common denominator was 12, and it makes subtraction or addition of our numerators a lot easier. Oh boy. Well, now we've got mixed numbers, which means we have some wholes that are being a part of our fraction. This can be a little bit more difficult. What I like to do is I like to break apart what we have. I've got 14 wholes, and I have 1 out of 2 parts that I need. And then we're trying to subtract 4 wholes, and this minus sign is going to go with both the whole number and the fraction. And so I'm going to also subtract 3/8. Well, let's do the easy stuff first. Let's combine our integers of 14 and -4. 14 positives and 4 negatives, that's going to give me a total of 10 positives. Okay, so now all I have to worry about is taking 1/2 and subtracting 3/8. And again, we've got to find common denominators. If I take 1/2, multiply both the numerator and denominator by 2, I'm going to get 2/4. If I multiply by 3, the numerator and denominator, I'm going to get 3/6. If I multiply by 4, I'm going to get 4/8. Wait a second. 8 is going to be my common denominator. Instead of using 1/2, I'm going to use 4/8. It means the same thing. It just looks different. 4/8 minus 3/8, that's way easier to get an answer. If I have 4 pieces out of 8, but I take away 3 of them, I'm going to have 1 piece out of 8 that I need. And so that's the other portion to our answer. We had 10 wholes after we subtracted 4 from 14, and after we subtracted 3/8 from 1/2, or what we called now 4/8, I ended up with 1/8. So our answer ends up being 10 wholes and 1 piece out of 8 that we need in order to make another whole.